Hello everyone, welcome to Embedded Systems. In this video we will be looking for the counters in 8051. Now as we know, we have two timer or counters, that is 0 and 1 in 8051. We have seen what are timers and how we code the timers. Let's explore how the counter works. Now in counters are used to count the number of pulses applied to the respective pins. In case of counter 0, the external pin is pin 3.4 of 8051, whereas for counter 1, the pin is P3.5. In using counter 0 and counter 1, we'll count the number of pulses applied to pin 3.4 and 3.5. So how to do this? So basically same as timers, counters is also having 4 modes, which is M0, M1, M0, M1, M2 and M3. Now these modes, same as in timers, are of 13-bit, mode 1 is of 16-bit, mode 2 is of 8-bit but having auto reload function, whereas mode 3 is 8-bit independent mode. Now as mode 0 and mode 1 are almost same, expect the number of bits, right? So let's go and explore this. So using mode 1 or mode 0, we can count up to, since mode 0 is 13-bit, we can count up to 2 to the power 13, and since mode 1 is 16-bit, we can count up to 2 to the power 16. Whereas since this is mode 2 is auto reload 8-bit, so it counts up to 2 to the power 8. Similarly, mode 3 counts up to 2 to the power 8 independently. Right. Now to define the use of counters and to set their modes, we use TMOD register. Now TMOD register we know is timer mode control register. So it consists of a bits M0 and M1, both for T0 and T1, or you can say C0 and C1 in counters. So basically the lower 4 bits are for timer 0 or counter 0, and the upper 4 bits is for timer 1 or counter 1. As the timer 0, or we can say counter 0, and timer 1 and counter 1 can be used independently with each other. That means we can use T0 and T1 independently. We can use T0 and C1 independently. We can use C0 and T1 independently, or we can use C0 and C1 independently. So these 4 possible combinations are present or available for access of counters and timers in 8051. So to set the modes in timer and counters, we use TMOD register, whereas the modes are set by M0 and M1 bits. So 00 indicates mode 0, 01 indicates mode 1, this is mode 2, and 11 indicates mode 3. So as we know, every mode is having different functionalities or different characteristics. We have to choose this, depends on our application. Whereas C/T bar indicates if we choose this as 0, it works as a counter, and if you choose this as 1, it works as a timer. Whereas this bit gate is used to control the start and stop of timer or counters externally from 8051. So as currently we are not going to control it externally, we'll keep these bits as 0. Similarly, these bits you can use in mode 0, mode 1, mode 2 or mode 3, same as in case of T0 and C0. Similarly, we can use this as counter or timer, and again gate as 0, right? So let's take an example in which we can explore the counters in 8051. So the example says we want to count the number of pulses in 1 second at pin 3.4. So first thing here to understand is we want to count the number of pulses at pin 3.4. Now as we know, 3.4 is corresponding to timer 0 or counter 0. We need to use counter 0. Next, we want to count the number of pulses in 1 second. So as we want to count in 1 second, we need to create a 1 second window. Now let's say this is my 1 second window. This is my 1 second. So in this 1 second, what do I do is I'll start my counting at this point and I'll stop my counting at this point. So whatever the number of pulses coming in these two instances will be for 1 second. So if let's say for example 10 pulses are coming between the start and the stop, then I'll get 10 pulses in 1 second. So this 1 second window we need to create because it is explicitly said that we need to count the pulses in 1 second. What it also means is the pulses in 1 second is nothing but the frequency. So in other words, the problem statement can also be formed like find the frequency of a wave connected to pin 3.4 of 8051. So the solution for both the problems will be same. Now we have considered two things from this problem statement. First is, since we need to use pin 3.4, that means counter 0, and we need a 1 second window as we want to count the number of pulses in 1 second. So before coding, we need to find the values of some registers. Now the values of registers means we want to find out the value of T mod. We want to find out the value of TL0 and TH0 as we are using counter 0. This corresponds to counter 0. And we want to develop a delay of 1 second or a time window of 1 second. So we need to use some different functionality of a timer and counters in that. So as we are using counter 0 for counting purpose, we'll use timer 1 to generate 1 second window. Now to generate 1 second window, we know we'll be using TL1 and TH1 as corresponds to T1. The 1 second window is nothing but a 1 second delay we have generated in previous programs, right? So what should be the flow of our program? The flow of program would be like to set the value of T mod. Once the value of T mod is set, we'll go and set the values of TL0 and TH0. The values of TL0 and TH0 will always be 00H as we are going to store the count value into TL0 and TH0. That means when we start counting the number of pulses, the value inside TL0 and TH0 will be incremented by 1 at every pulse. So let's say if I get a 10 pulses in 1 second, then the value of TL0 will be equal to 0 and the value of TH0 will be equal to 0, 0. So from 0, 0 to 10, it will be incremented for every pulse. So ultimately, at the end of execution, we'll come to know how many pulses we have detected at pin 3.4, and that value will be in TL0, right? As we know how to set the values of TL1 and TH1 for 1 second delay, we'll not go into that. Let's go for coding. So to count the number of pulses in 1 second applied to 3.4, pin 3.4 should be made as an input pin. Then we have to set the value of Tmod as 15 to set T0 as a counter and T1 as a timer, both in mode 1. We'll set the values of TH0 and TL0 to 00, as this TH0 and TL0 will count or will hold the number of pulses in 1 second. After that, we'll start the counter by setting bit TR0. Then we'll call a delay of 1 second and then we stop the timer by clearing TR0. That means the pulses will be counted in this delay. During this delay of 1 second, the pulses will be counted as we are starting the counter just before calling the delay, and we are stopping the counter just after the delay. So the number of pulses those were counted during this time will be for 1 second. Now, once the counter is stopped by clearing TR0, the count values equal to the number of pulses will be stored in TL0 and TH0. We have to move that values into accumulator and then to some memory location. So here in this line 16, TL0 is transferred to accumulator and then accumulator is transferred to memory location 50. Similarly, TH0, which is having the count of number of pulses counted in 1 second, is again transferred to accumulator and then accumulator to subsequent memory location, which is 51H. This is a routine written to generate a delay of 1 second. So here we call this delay by command acall. So this delay routine is repeated for 15 times, as this is generated by using timer 1 in mode 1. The mode 1 provides a maximum delay of 65,535 microseconds, and that's why we have to repeat this delay of 65,535 microsecond 15 times to get a delay of 1 second. So this program we used R0 as with a value of 15 to repeat this loop 15 times. Then we place the value of 00 into TH1 and TL1 so that we'll get the maximum delay using timer 1. We started the timer at this point by setting the bit TR1. Then we check for the overflow. Once it is overflown, we clear this flag TF0 and then we stop the timer by clearing TR1. Then we repeated this process 15 times to get a delay of 1 second. So basically we counted the number of pulses arriving in 1 second. That is the frequency of a wave as well.